Okay, so today we are going to explain about the IoT 4.0, which make traditional switchgear to smart iPanel. Okay. The first one that we will introduce about the smart iPanel outline, it will be in the following like IoT background, technical advantage, competitiveness, upgrade solution, and performances. And on the right below button that you can scan for our QR code, so you can download about the app. In here, that I will play a short video to let you understand. Okay, so from this video, you can see that there are two maintenance people that they are doing the maintenance work. So that for this part, you can understand that after the maintenance, it is normally you have to open the door. Yeah, but it is quite severe if there's anything that happens inside. So the people will be dead directly by this kind of accidents. And the next video is about the Russia. And then they are going to initiate the switchgear. So the guy is very lucky because he's just skipped these accidents. Yes, and finally that they find out there's something inside, so that they have to shut down by pouring the snow inside the panel. Okay. Through these two accidents that you can easily to understand, in here we have the importance for the switchgear temperature, which makes you understand why these kind of things will be happening, why we have to do online monitoring. The first one is about the breaker contact. So you can see here that this is the tulip and this is the cloud contact type. So after using for a long time, that insulation will be breakdown. So especially this is a withdrawable part, so you can easily to get damage for this kind of a VCB. And here is the cable run, and then if you lose the screw, and then it will be breakdown, and then caused by the resistance and temperature rise. And also here is the bushing insulation breakdown, also the same problems. So we care for your safety, and this is the reason why we have to do the electricity IoT. The first one is that we can provide the safety and convenience, so that you can do in a remote distance, and then you can have a better safety for our cabinet, and also for the smart switchgear that we can do like a safety control, preventive maintenance, transparency of electricity, efficiency about energy consumption, and also the information collection. And last one is the monitoring everywhere from your cell phone, laptop, or desktop. And one of the advantage for this one is about online monitoring, and also online alarming and AI function, safety control, and data storage. Okay. Our main function about AI function, it is it can compare about equipment degradation, which means if you have the transformer or a switchgear, that after 5 years installation, that it will get degrade for the component itself. So the efficiency will downgrade. So we can do this efficiency comparison between how much efficiency left, and then if there's any component that you have to replace after using for certain years. And the second one is that the estimated for next 15 to 30 minutes. So in this part that we will show the drawing, so that you can easily to understand what does the 15 and 30 seconds minutes meaning. And also we can get the overall data from the report, so that we can get the improved for energy efficiency. And last one is the friendly intellectual AI function, that you can get the information by the result of the AI analysis. This one is the advantage that we provide safety, cost, efficiency, alarm, message, analysis, maintenance, optimization, and remote control. So this is the all 9 courses for our database center. And here is the detail of the advantage. So Now, this kind of smart iPanel, it can manipulate for existing panels from medium voltage and low voltage, and also for the new standards following IEC 62271-200 and 61439-1 and 2 for the low voltage panel. Inside of the panel that we will install the gateway. This is the gateway out shape, and this is the front side, and then this is the back side. So for the out gateway, we support RS-485, which allows all the components with this kind of same RTU Modbus protocol can connect through our gateway to transmit the data and go online. And also in here we support Ethernet so that it can put this gateway inside the panel to get internet connection. And this one is the DIDO box. And the reason why we have to use the DIDO box is there's a digital input from the component and a digital output connect to our gateway. Yeah. And also this one is using for the components like VCB, ACB, or some other units that you have to do remote control. And then this one have to through this DIDO box to do this remote monitoring by our app and the web page. This is the overall structure that you can see. This is a medium voltage, and this one is the low voltage. So inside, like a VCB, ACB, or like a magnetic contactor, these all components requires to embed DIDO module so that it can connect with a cloud box, or you can say gateway, to transmit the data to our database center and then store through our server to give you the information collection. And other devices such as power meter, protective relay, and wireless temperature devices, and like sensitivity monitoring temperature, transformer. These things that they can connect directly through the RS-485 to our gateway to get the information. So this is the structure that we call the IoT 4.0. Okay, comparing to SCADA and iPanel system that you can easily to understand from the SCADA, it requires local computer to do on-site, and the main person the maintenance person have to be on there and then to help them to do the monitoring. And comparing to our advantage that we use the cloud storage, Microsoft Azure, and then this one can have a high security and you can access through any kind of devices. And the software maintenance is you have the platform maintenance is done from Taiwan, but for SCADA you have to charge every time for the modification, and the price is quite different for 5 to 10 times. And then also SCADA has advanced the system monitoring and for all the industry information, but we only focus on electricity, but we can integrate it with SCADA if it is required. And also for the app that they don't have app, they have app but they cannot do the control. And for iPanel system that we both support monitoring and control through our app. And also we have both the data analysis and also prediction for the next period of power usage. Okay, so next part, we'll jump into the web interface introduction and services. Here is the overall information, including area overview, device summary, energy consumption, demand information, report information, watt meter information, environment sensing information, schedule management, expert system, and system setting. Okay, first one is the login page. That for the clients that we will give them the username and the password by access. Okay, the first part we come to area overview, and in here you can do the comparison between this year and the last year for all the power consumption, and then it will display in kWh bar chart. And the second one is that you can here to see about the power bill display and then how much power it consumes and the energy use. Yeah. And the next one on the the left down button have the area structure. So in here you have the billing, and you can see here from your real expenses. However, this one will be a little different from the electricity company because this one is the reference calculation. And for your region's temperature, it can display also. Okay, and the next one is for the single line diagram. You can see about your meter's status, if it is connected or not. And also for the kW, and then how much power it consumed, it will be accumulated here. And you can also press this one to see the real-time power, so it will display in a bar chart. In this part that you can see from the downside, it has a 24 hours timeline display. And also in here, it is non-working hours. And the working hours. So you can see that the bars difference and also how much power it consumed. And next one is the device summary. You can select this part through the new summary, and then it has device information. So all the components from the switchgear that we will integrate for this part. Okay, and after you click for each icon, then at the bottom there will be a controller part. So after you click this, for example, as I previously mentioned, for the DIDO box that you can do the remote control. So after you press this one, that it has the on and off button that you can do the remote control through this function. The next one is the device summary. That we have different intervals, like 3 days, 1 day, hour, and also the available display function, such as voltage, power factor, real power, kWh, average line voltage, harmonic distortion rate. So these all functions can be selected on the right side. You can press this click, and then it can go down to display information. And then it will give you a graph. You can either be chart or it can be list. Okay. And also we have the dynamic information summary. It can also display about the meter, IPFR, or some other functions about the meters and the temperature. You can see from this side by putting your field about the company, drawing, so that you can easily to understand which panel has which figure. Next one, energy consumption statistic. So in here that they have the energy consumption kWh value, so you can see each day what does the curve goes, and also the comparing before and after installation performances in this part. Okay, for the demand information, this one can trace back to the AI function. Okay, let me explain in detail. First one is that you have the contract capacity. It is the 350 kW. And the second one is about the target demand. Normally, this one will be the 80% of the contract capacity. And the third one is about the predicted demand. This one is the predict for the next 15 to 30 minutes how much power that you will use. And this interval can be selected from the middle part. So there are 15 and 30 minute selection. And you can see from this timeline, for example, now it is in 31 minutes, 31, and then it will be showing for 15 from 30 to 45. And then for the purple part, this is contract capacity, and the alert value, it is 80% of this. Yeah, and then the target demand, the target demand will be 80%. So you can easily to see that your current demand and the next period of prediction, which part does it goes and then how much power will consumed. If this one will be less than the target demand, means that you don't need to worry and that your consumption will exceed your demand of your setting target. So what's the advantage of this part? You can easily to get the overall power usage by viewing this chart. So you see this one is your target demand, and then for most of the day that you use is below this one. So maybe after you collect after 1 year, and then you can use the overall database to reduce down your contract capacity, because you only use certain time which will exceed the target demand, but most of the time does not. So the overall averagely that you don't need to use that much. So this is a great way for you to reduce down the contract capacity by paying less money to electricity company. Okay, next one is about report information. So we have 3 parts. We have a yearly demand, monthly demand, and also the daily demand. So for this part that you can see, we have the full period, peak, semi-peak, and semi-peak on Saturday, and off-peak. But this one will be different from each country. So we can be customized depending on each country's electricity bill rate. And then you can provide how much you have to pay for each kWh, each degree, and then we can help you to set for that. And then for each demand report, we will show them for each hour and then divide into 4 columns. And these columns can display each kWh value. And then we will mark automatically by which one is the maximum daily demand. And then we can click the export for these figures into Excel file. So this Excel file can be copied and then to do your company own report usage. And the other report information for pie chart. This one is the function which can compare from this period. And this period and the previous period. And then you can see, for example, the purple line. The purple part is a manufacturing process. And this one is also. But the previous time you used 9.17%. But comparing to this time, it is 7.27%. So this is the comparison so that you can understand about your machine usage. It is used less or more. So if you are existing certain time, then we will give you like for example machinery comparing the previous one and this time. So you can see there's a green alert for you to understand how much power it exists. And also we can be display for each more detail to each meter, and then we can use this bar chart to display about the information. And then you can easily to check from here for the average price for each meter. Okay, and the next one is the watt meter information. In here, like you can choose about what is the like a main meter or this is a sub meter information. Okay, and then each individual meter can trace back the information, the maximum up to 2 years, and then it can also shows you the pie chart for each meter's consumption, so that you can see which circuit has the maximum usage and then which one is less. Okay, and also we have the environmental sensing information analysis. This one would be quite similar to previous one, but in here that not only display each meter's value, but also if you have the overheating information, that it can shows up from the field drawing. So you can easily to recognize for which component has the problem. And the next one for cross analysis management. This is can select for each meter, and then it can display for the drawing. And then what's the advantage of this is that, for example, if your component like capacitor, it is running, and then it is relatively, for example, you select like transformer. So this kind of figure should be going in a positive way, because when the component is running and then if need the power factor improvement, then it will initiate the capacitor to operate. So this graph is mainly focused on do the comparison and to understand if the component runs well or not. Yeah. Then the last part is that the system can also give you the subscription from each email. So each mail that you can see you want to receive daily or bi-weekly or monthly or yearly, and then this report will display in like a what period state. Okay, so this is the brief introduction about our iPanel system, and the next part will be the upgrade traditional switchgear to smart iPanel. This is and a different different way to enhance and upgrade your panels. As you see that we have the new panels, and it is very easy because it is from the original design. But how about if you have the existing panels? How can you upgrade for that? Okay, first let us to compare about traditional cubicle and smart iPanel. For traditional cubicle, that you have to do the periodical inspection, and then also you can only understand when the accident happens, and the data storage will be do the paper recording, and then remote control it is not available because it's only from the front panel to the operated, and also the energy management you have to turn off the devices while no use. Yeah, and then also it is only available in this way. And also the data analysis, no database recorded, so it is not able to do analysis. So our iPanel already improved all the informations and like continuous monitoring and abnormal information, and the data storage can up to 2 years, and you can do it in a safe distance, and also the big data analysis, so that you can use the energy more efficiently. And the data analysis also provide the prediction and analysis by the chart and the drawing and the graph report it display. Okay, so how can we do if the meter, if the panel does have the meter? So we have the one information. It is from cloud power measuring device. We call it CPN. This is a traditional switchgear that widely used for worldwide. So we can use our CPN devices, and it can be smart iPanel. How can that be? Because from this part you can see from the CPN it is a case which is portable, and then the front panel it have very clear and simple interface, have the meter and the gateway and the breaker from the on the top. And also it can support the CT and VT, and then these are the plug-in hosts, and also we can support Ethernet or Wi-Fi. And this is the brief introduction about the display and like how many times does the harmonic the meter can support. It can up to 31 steps, and also the voltage can be 80 to 480. So it is mainly using for low voltage panels. Okay, so this is a connection for the rear side. You see this is the VT, and also have the CT on the front. And also we can place these wires beside on the right side of the box, so that it can easily to bring everywhere, and then to easy to access for the installation. Okay, here is how does it goes. For the CT, that you just need to cross about the cables, bus bars from the breaker, and for the voltage VT, voltage clipper, to contact with the breaker as output bus bar, so that you can support the power to CPN. So you don't need to extra source other power supply. So this is the first one, very easy to do it within 5 minutes, and then to connect with Wi-Fi for the setting. And the second one is that we have the modularized smart devices. What's the difference from this one and to the previous one? We can see from this drawing. This is one of the case we did for Philippines, because they have many islands, and then it is not able for them to access to every part to do the initiative for the power. So they want to do the remote control, and we have the demo unit, which has the gateway put inside with the switches, and also the DIDO box, and then here is the terminal connection through the power relay. This one is the terminal connection through power relay, and then connect to this DI box. Okay, but the real one that we do, it can support 5 CB, and also the 5 PN and the 5 under voltage, and also 5 CO. Okay, this is the real one that we install. So you see that here are the 6 plug-in, but one is for spare. And then this is the terminal connect to the DIDO box through power relay, and then connect to the gateway. On the lateral side, there's a temperature detect sensors for humidity and temperature. And also we can support by 3 ways. 1 is Ethernet, 2 Wi-Fi, 3 is through you have the SIM card. You can use the USB transporter to supply internet to our gateway. And there's a remote and local switches that you can use. There's a terminal drawing that you can easily to understand which connection you have to do. Yeah, and from the CP1 to CP5, and the other one is for spare. Okay, so this is one of the case for installation performances. So this is the switchgear part, and then we can do the on-site inspection before installation. So we can determine, oh, okay, I have to install our panels here, and then this is after opening it, and then the cables should from the panels to the SPN, and then the connection from the low side to our SPN. So this one can do the remote control after the Wi-Fi is ready and the load is connect from the low side to our box. So it is a very easy way to access. But the only one you have to aware is that we have to obtain your devices, which is already being in our database, so that the protocol and the information can easily to get connected. Next part is about our temperature alarming management. So we have some of the information for you as reference. For temperature monitoring, that we have to monitor for the breaker, cable, and main bus bar, and also the temperature and humidity, and the capacitor, and also substation environment. So here's the detail for bus bar, breaker, cable, temperature detection. So for each part, that we have the bus bar, breaker, cable, and then you can display about temperature, humidity, and the sensor status, and the heater and fan. And then we have the relative substation environment, temperature, and the humidity. what's the important is that the VCB contact point that we have to do the instant temperature monitoring. Okay, and also we can support for partial discharge. How many times does the B happens for the partial discharge, and then you can accumulate it about partial discharge, and then to help you understand if there are any leakage of your electricity. And also we have the N330. This one is highly used for the IC panels. Since IC panels already diversify into 3 compartments, so we can place the N330 sensors into each compartment, and then like the photo showing here, on the button to detect each compartment's part, and or for bus bar room it is on the top, and for the cable room it will be on also in the middle of the cabin. And next one is about the capacitor. This one is we call it IPFR. It is Intelligent Automatic Power Factor Regulator. This one can automatically control for all the capacitor. It has the 6 sets and the 12 sets. Yeah, so if the capacitor have any degradation, then we can, through our app, that we can see what is the efficiency, and also how many times does the capacitor already operated, and the online capacity, how much kVAR, and how many times, how many efficiency does it left, so that we can understand when should we replace for the capacitor, and the status is on or off. It can also integrate with the resistor temperature together to be shown in the same page. Next is how we can do the VCB monitoring. We have the product which called Sengunity, and then this one have the HSR sensor for the substation environment, and then it has a sensor. This one sensor can be placed in the VCB 6 parts of the power side and load side for RST phases. And then it is wireless. It is transmitting by the acoustic emission wave to our antenna, and the antenna will connect to reader. Reader has RS485 output connect to gateway. So this is how we can get this information in our cloud. And each antenna can support 12 sensors, and then each reader can support 3 antennas. We also developed the specialized usage for the temperature display, which mounted in the front of the panel. And this meter can connect with SCADA and also HMI or other masters. And also on our iPANEL, this is all available. So you can see that this is real cases for cast resin transformer installation. So this is one of the connection, and then it is from the bus bar and also the insulator's connection point, and also for cast resin transformer, you can see this placed on the bus bar part for IC phases. And the next one is for the HSR that you place in the front panel, and then this one you can have the HSR mounted to detect the sensors and humidity, temperature and humidity. Okay, so you might be surprised how can it be sent and detect the temperature. So this is a reason by the chart that this is the temperature, and here is the frequency by megahertz. So we can compare each degree to which frequency. so we can have the relative temperature to shows. And this one is already proven by German laboratory. Next one is the performance that we did for Indonesia. They have the tire industry for total 62 sets. And then in here, you can see that it is mounted in the output of a VCB and the contact point of the bus bar. And then for the readers, we use a serial connection so that if you have many cases, then it can also be available. And this one is the St. Unity's HMI. So that if you have more than 10 sets, then it is available for this one to be easy to do the control. Next one is about our junior hotel. It has 18 sets. Okay, so this is also the inside from manufacturing for cabinets in our factory, and also we use this reader to give connection to our gateway, and also this is where the antenna goes, and this is the sensor at HMI. And this is the German engineer from St. Unity to do on-site instruction. Okay, and also the last part is the component temperature management. We also have the capacitor of the temperature monitoring. So you can use the N280. It is a by naming, and then we have the tile type sensor, which can be passed on the capacitor, and then this one can transmit a signal through this PT100 to our N280 temperature transfer module, and then to connect through the gateway to connect through ICE Wi-Fi to our gateway. And one is for the capacitor, the other is for the reactor temperature monitoring. So it is the other one is called probe type, and then it is mounted in the insulation paper of the reactor, so that it can transmit the instant information from the reactor to our gateway and then get the information. Okay, so that's all the introduction about our components and how our iPANEL did, and then what's the improvement from the first version. Thank you.